Welcome to another episode of Complete Developer Podcast, the podcast by coders for coders about all aspects of creating your best life as a developer.
I'm Will, the accomplished developer and aspiring software architect.
And I'm Beej, the journeyman developer sharing my journey in development. APIs, or application programming interfaces, are an important part of any modern web application. When properly designed, they securely expose data to authenticated and authorized users. However, not everyone designs them the same, which is why OWASP came up with a list of the top security vulnerabilities to avoid. In this episode, we're going to go through the OWASP top 10 API vulnerabilities, discussing each one in detail. Even if you are solely a UI developer, understanding the way security works within an API will help you to better interact with them. But before we get started, Will, what have you been fighting this week?
Well, we went riding bikes Sunday, my wife and I did. And I was struggling. I was like, okay, maybe I got the gears wrong. And I kept fighting with it and got about, 3 miles out and was just tired. And was like, hey, let's turn around. And then I went back maybe another mile to a mile and a half and finally got off the bike. It's just like pedaling was hard. It didn't matter what gear I was on. I'm like, man, I'm struggling. And that's when I noticed, I've been riding on a flat tire for some time. And, like when I was a kid, my bike, I almost never had flat tires. I don't know what kind of tires that thing had. That was like good old Walmart bike tires. It's not like it was, of course, there was quite possibly a little bit less weight on them too. So that was fun. Completely wore me out. I was good and sore when I got home. So the other thing I've been working on is the new website, and we're using Gatsby, and Gatsby has the attitude with GraphQL that Microsoft had with XML in the early 2000s. They use it everywhere, even if maybe that's not necessarily the way that you want to think about things. And there are some difficulties with debugging when there's a problem with the content, which when you have over 300 episodes put together over 5 years, plus, all other kinds of content, and some of it's linked and everything else, you're going to have content problems. And I can't find them. Basically, as a result of this, I have gotten frustrated, and I'm getting very close to having built a console and file system based content management system that can actually check invariants on like the markdown documents that we have in the site. It's absolutely ridiculous. I had to use JavaScript currying the other day, and it really saved my bacon. But the fact that I got to the point where I was like, I have to use currying, that's maybe not the best fun in the world, but it is going to be pretty slick. And I may pull that out and actually make something of it.
That was kind of funny because I had literally just been studying currying for my graduate class, and Will sent me, he's like, I just had to do this. And I'm like, huh.
Yeah. And it was one of those things. It's like, I like the idea of it. I almost always try to avoid doing things like that because it's sort of like meta programming. It's like generating code at runtime.
Yeah.
Cause you're kind of doing that, and people have a hard time debugging that. I've noticed they can't, like about half of developers just don't have a mental model for that and can't get there from here. So I try to avoid doing it, but it was necessary there to keep things clean. So it was fun. May pull that out, make an open source project. I don't know yet. So how about you?
I have been fighting Windows. Big surprise.
I like the currying better. Actually, I would prefer to shave a grizzly bear with a rusty spoon instead of dealing with Windows.
I was out later than I had planned yesterday, so I got a later start on this week's episode. I normally write them either Sunday or Monday. And so I get home and my mouse isn't working. It's a Logitech G502 Hero. I love it. I love that it's weighted. The thing is, the lights were on and G-Hub could access it and change the lights and all that stuff, but Windows wasn't recognizing it. It took me about an hour to get that resolved. Thanks, Microsoft. In better news, I got an A on my midterm. I only missed 2 questions. One was a BNF, and I see where I missed that. I made a mistake there. The other, I'm not sure it was wrong based on the wording of the question. the set of questions specified to do it based on Java. And that particular answer is like, it's different in the way Java does it than the way other languages do it. So I'm kind of questioning, did he mess up on that one? I don't know. But still, I got an A, so that's cool. Today is my friend Alicia's birthday. The artist who who allowed me to use her artwork in my talk, Med to Dev. She also designed the tattoos that Amanda and I got. Amanda and I were texting her earlier, saying happy birthday and stuff, so it made me think about that. Also, I am feeling better. I'm eating mostly normal, still kind of keeping it simple, though I am enjoying some bourbon tonight. Redemption bourbon. It's actually pretty good. And finally, I am going to get to play Kingdom Hearts 3. I mentioned it to a friend of mine at church. Said, oh yeah, put it on my Christmas list since I have the PlayStation 4 now. And he was like, oh, well, you want to just borrow it? I was like, yeah. He's currently borrowing Breath of the Wild from me. So I think that was Saturday, I said that to him. And Sunday, he brought it to me. Haven't gotten to start it yet. Been pretty busy, but guess what I'm doing after we record tonight?
Nice.
So that's going to be fun. I haven't played video games in a while, so I'm kind of looking forward to just, getting to do that. So, guys, take your financial confidence to the next level.
Lucas Casares is a fee-only certified financial planner and financial coach who serves tech professionals with his company Level Up Financial Planning, and he does this virtually out of Fort Collins, Colorado. So you don't have to worry about actually going and having a meeting. You can do this remotely, which is really nice in the current environment.
Yeah, Level Up Financial Planning, just like us here at Complete Developer Podcast, believes in the importance of having a real plan and taking action so that you can live your best life.
Yeah, it's really common for people to think that they're too young or they don't have enough investments to actually work with a financial planner. But Level Up's unique pricing model allows you to pay monthly and without requiring investment management. So you can start at any time. And, to be honest, why wait until you're old before you start getting help on your finances? Do this young and you'll be better off.
Yeah. And best of all, Lucas and Level Up Financial Planning is a fiduciary for his clients. And what that means is it requires him to act in his client's best interest. He's not a salesman. So many financial planners really just are trying to sell you something, but that's not Lucas. With him, you pay only as long as you're getting value, and you stop paying when you're no longer getting value.
And check out levelupfinancialplanning.com for more resources and more information. The Open Web Application Security Project, or OWASP, creates a list of security vulnerabilities for web applications every few years. While the general web application security best practices also apply to application programming interfaces, or APIs, in 2019, OWASP created a list of security vulnerabilities specific to APIs. This list focuses on security risks that are just within the API space.
Now, if you want, you can go back and listen to our episode we did a couple of years ago on the OWASP top 10 for web applications. I believe Will wrote that one, right?
Yes, and it actually got me out of an OWASP training at work because they were like, well, you got to take this course, this certification, like this, 45-minute thing, and I'm like, here is the podcast episode that I wrote on it.
Yeah.
I'll do it, but don't you want me to provide value?
Yeah. No. So as a major portion of web traffic involves accessing an API. They're at the forefront of innovation in web development, providing access to almost all of the data used in web applications. And you're going to notice a pervasive theme throughout this list is poor safeguards in APIs. Most of the time, this happens because something like a proof of concept code gets pushed to production when it was only ever intended to show that something was possible. I mean, I've seen this happen. Good grief, I'm working on stuff now that is replacing that because that proof of concept code reached its end of life, and it's like, all right, it's not handling the workload that we're putting on it.
Yeah, I've seen plenty of that proof of concept code make it out to somewhere like Stack Overflow, for instance, where somebody's asking a question and somebody goes, well, you'd kind of do it maybe like this, but you want to flesh it out for a real thing. And you get a copy paste developer who just moves it over and never does flesh it out. And yeah, it gets really, really ugly really fast. So there are a few terms we probably need to kind of bring into play here while explaining this. And these are the terms authentication and authorization. They get thrown around a lot in API development. And in this top 10 list, you're going to hear about them because it's kind of a big deal to make sure that you are who you say you are and you can get to what you're supposed to get to and not get to the things you're not supposed to get to. Yeah, it's funny like that. You know, it's like a storage locker. If you have a skeleton key for a storage locker and you're not supposed to, then it's not a storage locker. It's just a warehouse for thieves. It's the same principle. Authentication is the first step in security. It validates that the user is who they say they are before they move forward. The most common way to do this is through username password combinations. From here, some kind of authentication token is created for subsequent calls to the API. Usually you'll pass this on a header. Not always. I've seen people do it in query strings, which is always fun when they share those, but that's a topic for another day. Well, actually for later in this talk, probably. Now think about it, because it's probably going to come up. Authorization, on the other hand, is a process where the system allows access to specific resources or functions based on permissions. Authorization follows authentication, meaning that a user proves who they are before they're granted permission to access information.
In this episode, we discuss each of the top 10 vulnerabilities. And for each one, we first talk about what the vulnerability is and how it can be a problem. And then finally, we give ways to avoid or mediate each one.
And the first of these is broken object level authorization. APIs will a lot of times contain endpoints that handle object identifiers, and this can create a fairly large attack surface.
Yeah. In order to maintain a semblance of state, APIs tend to track the identity of a user within that API request. Will was just talking about how this tends to be in headers.
Just because somebody sends you a token or something that says I am this person, that doesn't mean they are, right? Like it's not the there's the one guy that the cop is stopping him and he said, well, I've actually got permission for this, and it's just a little piece of paper that says I do what I want. It is handy to be able to maintain state across calls, but the API cannot fully trust the user identity because an attacker could use another user's ID to gain access to their private data.
The issue here is that it's treating authorization like authentication.
Right. So for instance, if you know the GUID of another organization, being able to get in there when you're not supposed to would kind of be an example of this, right?
Object level authorization really needs to be applied on all calls to the API. So instead of having with authentication, you authenticate and then the subsequent calls use some kind of token or way of saying, hey, this has already been authenticated. You need to check authorization each time that comes in. So for each call, especially those that are accessing some type of data source, and even more important, if there is any type of critical data or confidential data in that source.
Now, another problem that can hit you is broken user authentication. So your authentication protocols and mechanisms and APIs are designed to provide access to sensitive data or protected functionality to people that have permission to do those things. If you do this improperly, attackers can compromise authentication tokens or exploit implementation flaws to assume other users' identities.
So this is sort of the other side of that, whereas the previous one was about authorization and getting permission to access things. This is coming in and saying you are someone else. If an attacker gains access to an account on an API, they're able to use that functionality that they shouldn't be able to access. They could steal confidential or important data, or even set up something like a denial of service attack against that API.
In order to provide adequate protection, authentication at minimum needs to implement proper authentication token validation, strong credential encryption, and login attempt limiting. And I'd also say probably in that mix is expiring tokens as well over time. It's funny how many people forget that one until they get told, hey, yo, dog, this token's like been around for a couple days. Maybe it shouldn't be in this banking API this way.
Yeah. And proper expiration too, because I think we'll talk about that in a little bit, but if you expire your tokens too quickly, that can be another problem. It's like the other side of the problem.
Well, because they'll have to go get another token. And, depending on what kind of load that puts on your system, that could be a problem. It could also be a problem if users are sloppy and in a hurry because you put them in this situation and they're used to that login box popping up all the time. When one pops up and it shouldn't because there's a breach, they'll type into it. If you bear in mind, you've seen Return of the Jedi. They're flying into the moon of Endor, right? And they do the shuttle code thing. And it's like, oh, it's an older code, but it checks out and they just let them on through. Don't do that to your API because your stuff will get blown up.
Now, it's interesting. We were talking earlier before we started recording about how Microsoft is encouraging developers to use REST protocols. And so when I was writing this, one of the things I found was that using encrypted JWT or JSON web tokens is a way for securely sending JSON objects, and it's considered best practice for authentication.
Which definitely beats out the old school SOAP approach, which is basically make things so difficult to work with that by the time the hacker gets the skill where he can actually deal with the thing, he could get a job that pays more than hacking. Just, hit it with economic. I'm being maybe slightly facetious, but I'm not overly patient with SOAP.
Yeah.
Just not my jam. I think Windows Communication Foundation should have been called Windows Transfer Foundation, just so that the acronym would be exactly what I think of it.
Well, that's why you're not liking SOAP. You're treating it like jam. SOAP does not go on toast, man.
There you go.
Sorry. I couldn't help it. All right. So the next, number 3 on the OWASP top 10 for APIs is excessive data exposure. Exposing yourself gets you on a list. Exposing your data gets you off a list, the payroll list.
I would imagine that probably both of those would get you off the payroll list. I'm just going to throw that out there. Unless you're
wow.
Unless you're, working at a political party or something. APIs are designed to expose object properties many times without even considering that individual properties may have different levels of confidentiality or sensitivity. This is compared to the objects that contain them. Prime example of this is when you get a user object back and there's a flag on there that says is admin. That user probably does not need the ability to mutate that and probably doesn't even need to be shown that or shown the names of the groups that they're in and those kind of things.
Yeah. I've seen one place where the user information came back and they had certain fields that were not supposed to be mutatable, and they did this on the client side. So all they did was make the display so that you couldn't change it.
Yeah.
But if you just go into the dev tools and turn that off, you could mutate that and it would go back up to the API, and the API, I'm guessing it was the same endpoint for officially making those changes as the ones where it wasn't allowed, because you could just.
This is one of those things where if you use a object relational mapper, this is why you don't expose your entities from the ORM out to the edge, right? Because you want to expose a subset of them, because what will happen is, or at least in the .NET space and a lot of others, you'll have a function that handles that endpoint, right? And you got a parameter coming in there that's of a particular type. The payload is, probably a post or a patch, just in general, maybe a put post or patch. Let's test the P filter on the microphone with that. But it comes in, right? And so it's coming in as JSON. It gets deserialized into the object that's coming in the function signature. If that object has the stuff that is sensitive in there, you can mutate it just by doing that, especially if you just take it and say, okay, yeah, I trust them, save it, because you go, oh, the UI doesn't do this. Well, if the endpoint does, that's a great way to get hacked. So typically what I'll do, and I'm pretty sure you do the same thing because it's kind of sane, is you use DTOs for that so that you limit the scope of that injectability to just the fields that can actually be changed. I showed this to somebody in a system one time, and their conclusion is the web is not secure. And it's like, well, being dumb is not secure. Has nothing to do with the web.
No, what I like to do is I have actually two different sets of data models. I have the view model, which is this is what goes
outbound.
Yeah, the outbound. It's what gets exposed.
It's a result of the query side of things. Yeah.
Yeah. And then I have the data model, and that's what the API uses and the ORM uses.
Yeah, I typically have a command model coming in, and then I use that to mutate state on the ORM. I mean, like we're using Entity Framework at work, which I don't think that's too bad to say out loud. In the past, I've used Dapper, those kind of things, but there's always a point of separation where I kind of have to manually say, okay, now glom all these properties in to this thing, because I don't ever want that happening automatically. I've seen people do that with stuff like AutoMapper. And the thing about that is they'll get wild and they'll start out and they'll say, okay, I've got this object type that's the DTO coming in, but I don't really want it to be that. I just want it to be a dynamic. And that way I can send whatever I want to send and it'll map it. And then they auto map that over, and bad things happen to kind of not forward thinking people.
Yeah. AutoMapper is a great tool if used properly.
Right. Like nuclear fusion.
Yeah. Yes.
It's got to be in a contained area, and you have to be doing it intentionally.
Yeah. Now we've kind of hit on several of these with our examples that a lot of times developers design APIs to allow for bulk data transfer with as little as possible overhead on the client or the server side. And then they rely on clients to filter the data before exposing it to the user. This is really a bad idea, guys. And then because of this reliance on the client to filter sensitive data, a nefarious listener could access sensitive data through simply analyzing the traffic between the API and the client calling it. I mean, all you have to do is go to Chrome, open up DevTools, and go into the network tab.
Yeah, and I've done this. I worked at a company where they sent data back that was used in validating, what was filled in a form that was a purchase form. So it had credit card, PCI data in it. It's been a while. But they would basically take the user's existing credit card information and pull it in and send it down to the client.
Wow.
So that when the user submitted that form, they had the real credit card number and they could validate and not break the form. That way they didn't have to think about, okay, did they enter a new one or not? And it's like, but guys, you sent their credit card number down. Like PCI does not let you don't do that. And yeah, it's just hanging out there in the JSON. I don't know if it's fixed yet or not. I know for 2 or 3 years afterwards, it was not fixed, but at the rate that company's going, they're going to be out of business before too long anyway. So it probably doesn't matter. API endpoints should implement data filtering to return only properties that are needed for a specific use case. Testing should include validating all API responses to prevent excessive exposure. One thing that you'll also see a lot of times is where the client actually specifies which fields they need, and you don't send anything else back other than those things. That's very handy.
Yeah, I've seen that. Yeah, I've totally seen that. That's actually a really good thing. I've actually trained our QA team to do exactly this. I set up Postman for them. They can test just the API endpoints and make sure like things aren't coming back without having to go into DevTools and stuff like that. They can just see exactly what's coming back. That has actually really improved our security and our quality of life for our QA team.
Yeah, Postman's great.
So number 4 on the top 10, lack of resources and rate limiting. APIs are built for automation and allowing programs and apps to access them without human intervention, making bulk actions and repetitive operations easier and smoother.
However, When you make repetitive actions easier, repetitive actions happen. A friend of mine in college, there was a Sony website where like there was this CD, and if you clicked on the right spots, you would win a prize. Well, my friend crashed Sony's web server with a little bit of browser automation. And like actually got in a little bit of trouble about it. I mean, he talked his way out of it and they kind of had a good laugh, but it was a bit dicey there for a minute because they didn't rate limit those calls. Each call to an API is going to consume resources. It chews up network bandwidth, it'll chew up CPU cycles, it'll chew up memory and storage. And this impacts the performance of the server where that API lives.
Now, denial of service or DOS attacks are an attempt to crash a server by rapid or high volume requests to an API, which either doesn't have rate limiting parameters, such as execution timeout, payload size limits, etc., or it may have them set too high or too low.
One thing that I've seen in a few situations is where they have rate limiting in place, but the code that kicks in when the rate limit happens is doing all kinds of logging and all kinds of other stuff that's actually more expensive than what would have happened otherwise. And I mean, it's really easy to do, and you just get nailed and your server falls over and you think that your mitigation plan worked and it was actually what killed the server.
Mm-hmm. That's a real tricky thing here because when you're building it, you're thinking about mitigating the problem when it is a one-on problem, but you're not thinking, all right, how would I exploit this? And that's just something that, if you have a good QA or a good security team, they're going to test for that. But as a developer, we don't always think that way. I mean, it's a good process to get into. It's like, all right, how would I exploit this?
Well, I mean, I've written systems before that, they were designed for maybe 2 or 3 requests a minute just because of the nature of what they were being used for. And that's fine. But a year after I left, somebody else had bent that system to try to handle hundreds of calls per second. And it did not go well. And it's not a scaling factor that I failed to build in because it was for a single use case and somebody copied and pasted the code.
Yeah.
And so this will happen to you too. It's not a statement on your developers. It's just like, hey, the situation changed. You need to figure out what you're going to do about it under the context that you're in right now, not what you thought it was when you wrote it. You really have to make sure that you have size and rate limits in the specifications. You have to validate queries and request parameters and set resource limits for runtime environments. And it's really tricky thinking about things like rate limiting. Like that is harder to implement correctly than a lot of people, I think, suspect, especially in an environment that is inherently stateless and might be across multiple servers.
Mm-hmm.
Yeah, definitely find somebody else's solution. Don't try to write your own. I've done that too, and mine worked, but it's just not worth it. It's just miserable.
And this is also going to very likely involve working hand in hand with the operations team.
Yeah, because some of the things that can cause the problem are kind of in their realm, and some of the things that you use to mitigate it are also in their realm, and you probably don't have access to either or all of it.
Yeah, we ought to do an episode on DevOps.
An episode or two.
We kind of hit on the issue in a couple of them. In a couple of episodes, we kind of skirted around it, but we should do that. Number 5, broken function level authorization.
So an API can be designed to do a lot of different operations. Some APIs only need a single level of access for all users and operations, whereas others have different levels of functionality so that one set of users may not have access to the things that another set of users can do. So like your administrators versus your basic users, for instance.
Or one thing that I've seen a lot of is customers versus employees.
Yeah, and it gets even more fun when you do that, because what about your support employees when they need to see what a customer is seeing? You have now support that are impersonating clients, but there's stuff that they can't touch as a support person impersonating the client that the client can touch. Yeah, I just dealt with some of that today, and it's just like you're looking at it going, I can't get my head around it.
No, you gotta like almost like get a whiteboard out and map
That's
out
what's going to
the
happen
whole
tomorrow,
thing.
probably. I just got to figure out which of my markers is good back here. Hope they didn't all succumb to COVID.
Yeah. Broken function level authentication occurs when an API doesn't check for permission level before granting a user access to certain functionality.
Yeah, and this is really bad when you have things like security through obscurity, where you just try to hide functionality that should not be public, but isn't restricted by not, actually keeping them out. So like, you put it in the documentation, or people can see calls that go to it, or it's just discoverable in some manner. It's really bad. Like if you're using the hate OAS thing and you put in the links section, where those calls go, but they actually can't get it.
Well, see, like this would be where you have that functionality exists, but it's not in the documentation. So you don't tell the users, oh, hey, there is this call. Like it's basically like having a public.
It's a public-private API. Yeah.
Yeah. Yeah. It should be private because it really shouldn't be accessible outside of the API, but you made it public. You just didn't tell anybody that it was accessible. You have told a story about this before, and I cannot remember it off the top of my head.
There are so many that I have seen. And I guess I'm going to protect them. I'm going to protect the guilty slightly by extending their security through obscurity to include this podcast, because I think some of them are going to get nailed because some of those people were not as responsive to, hey, this is a security hole. Well, who would find out about that? Because, there's nothing listing all these endpoints, but dude, all you got to have is a disgruntled employee that leaves. If you're doing things this way, you probably also have disgruntled employees and a fax machine.
What I was thinking when I was writing this was when we have talked about deprecating systems in other episodes, you had a story about, and I don't remember the full thing, but you had a story about how you were using something that wasn't officially an endpoint.
Yeah.
And then they took that away in the update. And like, oh, we were talking about like using bugs as if they were features. And you were using access to something that technically wasn't supposed to be there because it was basically security through obscurity.
Yeah, it was an API that was exposed in obfuscated JavaScript code that I managed to get into and figure out like what was actually going on there. And they tried to be clever, but they didn't have a good obfuscation engine, because it was slightly worse than being minified. So they were trying to do some things to make stuff harder, but it was like symbol replacement. And so you could just go in there and say, okay, here's the variable I. Well, what is I? And you go up and you look where it is, and you figure out what it is, and you give it a useful name, and you go through and manually replace it in Notepad++, and you go back, okay, now what's the next variable? And people do stuff like that. There's damaged individuals like me that will do that. So,
hey, you know what? At least you admit that you're damaged.
Well, I mean, I think honestly saying that I did that probably is the admission. You just got me saying I'm damaged afterward is just the checksum that you heard what you thought you heard.
I couldn't remember the exact story, but I was thinking of that when I was writing out this part of the episode. And I'm like, I just put a note in there. Will has a story about this, and that's it, because I knew there was one. I just couldn't remember off the top of my head.
And the thing is I did that, and it was like 6 months later that they removed that because they found out, they're like, hey, this isn't a real good idea. And I had to call support, and they're like, how did you even know about that? Did somebody leak that? Do we have, like they were asking me all kinds of questions, and I'm like, no. I forgot how I got this information. My bad.
Yeah. So guys, the trick here is to act like a politician, or act like the way they write laws, deny access to everything, all endpoints, all functions by default, then allow it based on explicit grants. So if you look at the way a lot of laws are written, they actually blanket make something illegal.
Except for the way they do it.
Yeah. Except in this case, except in that case, except in that case.
So the next issue is kind of dovetails nicely with what you just said, and that's the mass assignment issue. APIs, especially in object-oriented languages, take in objects with sets of properties which may or may not be set by the user. Mass assignment occurs when an API assigns values to properties that the user should not have access to modify or create. This was the thing I was talking about with JSON deserialization and how you can jam something in there that should not go in there, but does if you're using the wrong type exposed on an endpoint.
Yeah. Now, another thing that can happen here is if somehow an attacker or someone learns the data model, like figures out what that data model is, if you're not careful, even if that's not exposed, like even if you say have a the view model versus the data model that only shows certain things, but if it allows them to pass in dynamic objects, then those can come in and they can go, hey.
And what's funny about that is API best practices generally say, hey, use something like Open API and actually expose what your API is, including all the object specifications that go in and out. You cannot get away with security by obscurity on this one. Like, you have to have best practices in place or you will get nailed eventually by this.
When an API takes in properties and assigns them without checking if the user is authorized to make those changes, an attacker could add in information to a request that modifies properties that should not be modified. One example that we gave before is the isAdmin. A big thing here is upgrading privileges.
Yeah, which realistically should never be a property on a user model anyway, because it's not really granular enough for most uses, but people do that. One thing too is don't map client inputs to internal variables and just kind of have a whitelist of properties that a client can access to avoid allowing nefarious users unintended access. So picture a user on the open web being like somebody walking up to you at the fair and giving you food. If it's somebody you trust, you might trust some of the food. But if it's some rando, you probably don't want to take that candied apple, right? Because Lord only knows.
Yeah. That's a good way of putting it. What I was thinking here is with your APIs, let's say you either have an isAdmin or you maybe just have an enumerable role. It's customer, employee, admin, support. Like, let's say you have that. We'll go with that. You have the user's role. You're going to want to expose that even on the UI, because like the client side, the front end is going to need to know, oh, hey, we show these options based on the role. But you want to make it so that when it comes into the API, that cannot be changed, except maybe through certain endpoints. Have a way, obviously, to where it can be adjusted, but that's not something that you want to go, all right, if this is different, either trigger a, hey, something's wrong here, or just deny them.
Yeah. I mean, in other words, don't default to trust because you have crossed a trust boundary when you leave your API and you're going into a system that is compromised.
Yeah.
Like the user's browser is always a compromised system as far as your stuff is concerned. It may be locked down, tight as a drum. It may be the head of the NSA's personal computer secured by his entire team. But as far as your web app is concerned, it is compromised because you don't know what he's doing. You have somebody in there that isn't an admin on your system. Well, okay, it's NSA, so he probably is. So speaking of that, the next one is security misconfiguration. This vulnerability is somewhat of a catch-all for any risk or problem that exposes confidential information or allows for attacks.
Yeah, so poor default configurations, incomplete configurations, useless or unused HTTP methods, improper HTTP headers, poor cores or cross-origin resource sharing implementation, and even unfiltered error messages are all potential causes of security misconfiguration. Not too long ago, I ran across this in something I was building. Like, I didn't catch it until we switched from dev to test environments and the database password was different, but it didn't get updated in the config. And because of that, the controller didn't get built. And that sent up, so the logging was starting at the controller. It was assuming that was working. I guess this was a while back. This was an older app because it wasn't .NET Core where I have the logging at the program level where it would catch that. But, and so it was sending this full detailed error message up, and thankfully caught it before it, made it any further. But that was one of those things. It was didn't even think about that.
Yeah. And it's interesting what is available in a stack trace that gets dumped sometimes, because it can show what dependencies your app has. It can show how you're interacting with the database. It can show the web server version, which is going to be kind of somewhat something you can get anyway. It's a grab bag of stuff that a hacker would love to have for determining how to attack your system. And bear in mind that this doesn't necessarily protect you if you fix this. It's just that it makes it harder to get in. And so they go somewhere else instead of bugging you. And you have time for the real dangerous penetrating attacks that are, executed by competent people instead of constantly fighting off all these script kiddies that are going to try to do this.
Yeah, attackers tend to target APIs because the whole purpose of the API is to expose internal data.
Well, that and browser automation is awful.
Oh, yeah. Because of this, any vulnerability at any point in the API is an attack vector and needs to be treated as such. It's like Will said, once it leaves your API, it is unsecure because you can't trust that it is.
You also need to be careful and avoid permissive configurations and sharing. So that would be like with cores when you say, hey, this can go anywhere. If it's not supposed to go anywhere, don't do that.
Yeah.
Because that open cores is bad. Okay. And you need to enforce consistent security across your API stack. You don't want to have some areas that are secure and other areas that are not because you hadn't gotten to them yet, because people will also kind of poke at that kind of stuff and go, well, why is this way? And this other thing is this other way. And if they don't see a justification for it, it's just like you hung stink bait out in front of a catfish. They're coming.
Also, you want to use repeatable processes when you're deploying your APIs.
So in other words, the junior dev telling him, where to click in Visual Studio and where to copy the files manually is probably not going to do it, because it's not actually considered a repeatable process, even though you probably repeat it considerably.
Mm-hmm. Automating deployment is such a blessing.
Yeah, it is nice. I mean, our build pipeline in Azure is dog slow and we're working on fixing it, but it's really nice to get something up there, get a PR approved, and then 15, 20 minutes later, it's out on the server.
Yeah.
And I'm not configuring stuff. I'm not turning stuff off, turning stuff on, trying to make sure I got the config file overwritten or the environment variables like they need to be. It's all done.
Before we had the build process, it was like you'd have to go in and make sure, because I would have different branches for the different environments. So I didn't have to go in and remember, all right, make sure it's pointing to the right database, make sure it's pointing to the right log, or make sure it's pointing to the right this. But now it's, you push it up, get it in dev, make sure it's working. When it goes to test, you just click that it's ready. And the other nice thing is QA, the way we have it built, QA is the gatekeeper for test. And so if they're working on something, we're not going to mess them up. It just shows up, hey, the next build is ready to be deployed when you're ready for it. And it makes life so much easier when you have these automated processes like that.
Well, and when you don't, there's going to be some dude at 10 o'clock on a Friday night who has to do a deploy, and he's going to change configuration settings and do things like enable write access to the directory because he just can't be bothered with it right now because he wants to go home and go to bed. And if you don't have the automated processes doing stuff and configuring your environment, configuration as code type setup, that change he made is now permanent, at least until you get attacked, and then it's there. You can really get broken into very quickly if you're not being careful about this. Injection is the next one. Injection has been in the OWASP top 10 list since its conception. It's going to be there until the heat death of the universe. I'm just going to go ahead and tell you, this will always be in the list. It was number 1 in 2017's list for web applications and number 3 in the top 25 most dangerous software errors.
It's a big issue, is what we're getting at. Whether it's SQL, NoSQL, or even JavaScript, injection happens when data sent in gets interpreted as a command or query instead of as data to be stored.
Yeah, and improperly or poorly sanitized data can be mixed with code into a single command, and then the command gets executed. That data becomes code in some way. It's concatenated in, it's sent in as a parameter. It's the whole little Bobby tables thing. The reason this is going to always be there is there's always going to be things that are too dynamic to do without some kind of dynamic code generation. Queries are a prime example of this. Anytime you got to query something, if you're doing advanced querying and filtering and sorting, you're passing in column names. You're saying, here's the order you sorted in. Here's the way I want you to query this, etc. That gets passed in. SQL gets built from it. If you did it wrong and somebody was able to put a single quote in there and the right escape sequences, they can put code in that gets executed with the permissions at the web server, and bad things start happening. The reason I say this problem is always going to be there is because people get rushed to implement features, especially get feature parity, other competitors. And this tends to be an area that I see where people do this a lot. They'll be like, oh, I can implement this real quick. And they don't think about the security, constraints around it. And they make a naive implementation and they get hit by this. So it's going to be on the list forever.
So what you want to do is sanitize your input data by validating, filtering, and encoding all inputs from API requests, both client-supplied and those coming from external systems.
Yeah, and parameterized APIs will restrict inputs so they don't directly use external inputs in queries or commands. Object relational mappings help automate this process. This is one of the things that ORMs do reasonably well.
There's a lot of things that are annoying about them, but this is one of their benefits.
Right. Now, the other side of that is a lot of like your micro ORMs still do a pretty good job of this. So you don't have to use a full-blown one. You want a layer in here that you're not maintaining that does that.
So number 9 is improper assets management. Documentation is of even higher importance with APIs than other web applications because they often expose more endpoints, more ways into the system. And so system changes happen over time, and so do the ways that they're accessed and their dependencies. API assets need to be properly managed to avoid security risks.
Yeah, and endpoints often will become deprecated over time, but they're not removed because maybe there's one or two clients still using it in a specific use case and your code accounts for that. But the problem is if somebody else does it, does that create a security vulnerability? And a lot of times it does. Documentation is the trick here. If possible, automate the documentation generation process so that it's always up to date. Like OpenAPI Swagger stuff is how I've done this traditionally in multiple jobs. It works really, really well. But you have to have something. And you also have to make sure that environments always remain separated so that you don't have access to one environment from another one.
Yeah, so I've actually seen this. I couldn't believe it. I was doing some consulting and it turned out it had been, the code was being used for something that it was never built to be used for. It goes back to that proof of concept thing we were talking about earlier. They were passing in the server environment for the database into the API. Now, mind you, this was a microservice kind of thing, so it wasn't exposed to the web, but other APIs were calling it, and they were passing in, oh, this goes to dev, this goes to production, like that kind of stuff. Like that was the first thing I noticed. I'm like, this needs to change.
Yeah, I mean, that's an old problem, right? Like if you look at how much mail you get in your mailbox for other people, we have an organization here in the US that spends billions of dollars and doesn't get that perfect. So like there's no reason at all for you to be doing that in a server environment. Like you can't get there from here. So don't ever do that.
Well, I mean, even if you're calling API, the caller or the client is determining which server it's going to, that should be, all right, to go to dev, we call to the dev
server.
Yeah. Like we call to the API that's in dev, so then it goes to the dev database. That way you can restrict, hey, you can't call into, like, from an operations standpoint, they can just restrict, hey, development can't call into production.
Yeah, and developers, I've known developers get mad about that. But like, dude, you don't want access to production because then it's your problem. Like, it doesn't increase your pay enough for it to be your problem. So speaking of things that don't increase your pay enough to be your problem, insufficient logging and monitoring will get you in trouble. Studies of API security breaches show that the average time between when a successful attack occurs and when it is detected is about 200 days. And that the majority are found by external users instead of internal monitoring.
Yeah, API security is not something that's a one and done thing. It shouldn't be set up once and forgotten. Instead, it needs to be constantly monitored. And if it's not properly monitored, attackers can disguise their attacks for long periods of time and even use the initial attack to maybe a lesser API or something that's not really critical to ultimately gain access to other systems on the server.
Or other systems that even aren't on your server. Like, they can get your mother's maiden name and birthday off of something. They can do a lot of very interesting damage to your financial profile.
So what you want to do here is start out by defining normal activity of an API and then figure out what constitutes suspicious activity. From there, create alerts for when that happens. You may even want to use a monitoring system to maintain detailed and secure logs of access attempts.
APIs are access points for services and web applications that provide an attack surface for nefarious users. That's not their primary goal, but that ends up being one of the things that happens if you're not careful. This list of the top 10 vulnerabilities is just the beginning of API security. Use it as a starting point for securing the APIs you design and build. And when building or securing an API, you may want to consider, something like a vulnerability scanner to help identify weaknesses in your security. And this, by the way, could be a vulnerability scanner that is actually a person. Get a security team in there if you are touching anything sensitive, because you don't want to be on the receiving end of what happens when this goes wrong. To help in securing your web applications, OWASP provides a series of cheat sheets with concise information about specific languages and or protocols for web development. And there's going to be a link to that in the show notes.
Yeah. So we want to give another shout out and a huge thank you to Lucas from Level Up Financial Planning for sponsoring this week's episode. Through his sponsorship, Lucas is helping us to achieve our podcasting goals, just like he will help you achieve your financial goals. That pretty much wraps us up. Before we close everything out, Will, what do you have for us this week for Tricks of the Trade?
Talk about web security and just security in general. There's a lot of principles, I think, that apply to your personal life as well. For instance, being careful to authenticate where you're getting information from. Making sure that the person is actually qualified to provide you information. From a medical perspective, this might be, hey, I actually talked to a doctor about, this weird lump on the side of my neck, versus Jennifer over here with the healing crystals says that it's this other thing, right? That's an authentication issue. You're going to similarly see things with authorization issues. You have people who will talk down to you, who will discourage you. And the fact is they're not authorized to do it. If they're not somebody that you would go to for advice, they're not somebody that you listen to their advice either. That's an authorization thing versus an authentication thing. You have similar things pretty much in your life. Like, if you start actually looking at your personal interactions and going, okay, if I was a web server and this person was a hacker, are they getting in or not? It can be really illuminating sometimes as far as the things that you're made to feel or the things that you are made to react to that maybe aren't entirely appropriate or useful for you. So just kind of play around with that mental model and see where it gets you, because I've done that at different points. It's been very, very eye-opening. Sometimes not in the most pleasant of ways, but it's always interesting. So that's pretty much all I got.
Stand by for Titanfall.
If you have a question or comment, please email us at neckbeards@CompleteDeveloperPodcast.com. Our theme music is an excerpt from Stand By for Titanfall by Pure Bells, available on SoundCloud and licensed through Creative Commons.
The intro music for IoTs is Hillbilly Hip Hop by Jason Belcher. For references, show notes, and to sign up for weekly emails with extra tips and insights, be sure to check out the website at CompleteDeveloperPodcast.com. You can also follow us on Twitter at CompleteDevPod and like our page on Facebook to keep up with news about the show. Catch us each week as we broadcast live, talking about what's going on in the tech world and answering listener questions.
Learn more about all of our shows and groups by going to CompleteDeveloperNetwork.com, where you'll find links to Junior Developer Toolbox, Developer Launchpad, and our other communities. Thanks for listening. See you next time.